From the parent functions, we get transformations. Transformations of functions rely on the parent graph, which is an anchor graph from which all other graphs are derived. You have two different types of transformations. You have rigid transformations. Rigid transformations do not change the size or shape of the graph. It only moves it. So there are two different types of rigid transformations. We have reflections and we have translations. If you multiply by a negative on the outside of your function, then that reflects the graph of the function over the x-axis. If you multiply by a negative on the inside of the function, that's going to reflect the function over the y-axis. With your translations, you can shift a function vertically and horizontally. If you add c outside, that moves the graph up. If you subtract c outside, that moves the graph down. Now, if you add or subtract c inside the function, then you're moving the graph horizontally. And horizontal shifts are different because they move in the opposite direction of what the sign tells you. So when I add inside the function, I'm actually moving left. And when I subtract inside the function, I'm moving right. The other type of transformation is called a non-rigid transformation, and it's going to produce shrinks and stretches in two different directions. You can shrink or stretch horizontally or vertically. The way you determine it is based on the location of your multiplier. So if you are multiplying outside the function, that's a vertical stretch or shrink. If you're multiplying inside the function, that's a horizontal stretch or shrink. For vertical, if the number you're multiplying outside is greater than 1, we call that a vertical stretch. If the number you're multiplying outside the function is less than 1 but greater than 0, we call that a vertical shrink. Now, again, horizontal stretches and shrinks are going to behave in an opposite manner, just like with the shifts. So if I multiply inside by a value greater than 1, that is a horizontal shrink. But if I multiply on the inside by a value less than 1 but greater than 0, that is a horizontal stretch. So let's try a few examples. In numbers 1 through 9, you are identifying the parent function and the transformations. So in number 1, this is a cubic function. My parent function is f of x equals x cubed. And then I identify the transformations based on the equation. I'm multiplying outside, so that is a vertical stretch by a factor of 2, and I am adding inside, so that is a horizontal shift left 1 unit. The next one is a quadratic function. Its parent function is f of x is equal to x squared. And based on the equation, we have a reflection in the x-axis because of the negative on the outside. We are subtracting inside, so that's a horizontal shift. That's a horizontal shift right 11 units. And we're subtracting outside the function, so it shifts down 5 units. The third one is an absolute value function. Its parent function is f of x is equal to the absolute value of x. Now, anytime you have a multiplier like this, you always want to factor it before you determine any type of translation. So this is the absolute value of 3 times x minus 2 when it's factored plus 8. So I have a horizontal shrink because I'm multiplying inside and my value is greater than 1. That's a horizontal shrink by a factor of 1/3, because if you're shrinking, it needs to reflect the fact that it's getting smaller. Remember, horizontals are opposite. So even though it says 3, we're shrinking by 1/3. My translation, this -2 means that I have shifted right 2 units, and my +8 means I have shifted up 8 units. And number 4, this is the square root function. And the parent function for a square root function is f of x is equal to the square root of x. I have reflected in the x-axis, but if I factor this inside, this is -5 x plus 5. And remember, you should factor before you determine any shifts. So this is -x minus 5. So I have not just reflected in x, I have also reflected in y, because inside my radical is a negative multiplier. I have a vertical shrink by a factor of 1/2, and I have shifted right 5 units because of my -5. Number 5, this is what we call a logarithmic function. The parent function of a logarithm is just f of x is equal to log of some base b of a. So in this case, we have reflected in y because of my negative inside of my log, and I have shifted up 4 units. And number 6, even though I have a base of e, this is still an exponential function. Still an exponential function. It's what we call a natural base. So the parent function is f of x is equal to e to the power of x. We have a vertical shrink by a factor of 1/3. we have shifted right 1 unit and down 4 units. And I have no reflection in X or Y. And number 7, this is a reciprocal function. Remember, the parent function for a reciprocal is f of x equals 1 over x. So first things first, I have a reflection in x because of my negative out front. To get the 4 on top, I had to multiply that 1 by 4. So that means I have a vertical stretch by 4. And then down here on the bottom, I need to factor that. So this is 2 times x plus 3 over 2. So I have a vertical stretch by 4 and a horizontal shrink by 1/2. I have shifted left 3 over 2 units and down 19 units. The next function is what we call a greatest integer function. You are most familiar with greatest integer functions as a step function. So its graph looks something like this, where it looks like you have stairs that go up. The parent function equation is just the greatest integer of x. So based on this parent function, what kind of transformations do we have? Well, we have a horizontal 1/4 inside means it is a horizontal stretch by 4 because it's the opposite, and I have shifted up 5 units. Number 9 is a cubic function. Its parent function is f of x equals x cubed. This is the same as saying negative x cubed plus 4. So I have a reflection in x, and I have shifted up 4 units.